Now another set of questions regarding the rolling motion. Here I have taken one question as we have to find the expression of kinetic energy for a body rolling without the friction. As we know that kinetic energy is given as the sum of kinetic energy of translational motion with respect to the center of mass and translational motion with respect to the center of mass. Since the body will roll down but it should not slip, S-L-I-P slip, not S-L-E-E-P slip, okay. So kinetic energy for translational motion will be half mv square, where v will be for the center of mass velocity, and rotational we have half I omega square. Then to find the moment of inertia we have to find the radius of gyration, because here the body is having considered for the center of mass. Body's motion is considered for the center of mass. So the rolling body is having the radius r, and let the radius of gyration be k. So the velocity is taken in terms of omega. We have v is equals to r omega. If you simply remember this one, v is equals to r omega, and radius of gyration in terms of moment of inertia is given as I mk square. So where there is velocity and where there is I will substitute these values, and then if I solve, I will get the expression of kinetic energy for a body which will be rolling down without slipping. Now to find the motion of a cylinder rolling down, that is, if the body is a particular shape of a cylinder, then what will happen? In that condition, you have to consider the acceleration as 2 by 3 g sine theta, and the friction is 1 by 3 mg sine theta. This is the perfect values which you have to use to understand the concept of rolling body or rolling motion of a body particularly shaped in the form of a cylinder. So here the question signifies the same, whatever I have just told you. Here you can see a cylinder of mass 5 kg whose radius is 30 centimeter rolling down an inclined plane at an angle of 45 degree, means theta is given. I have to calculate, clearly it is written as force of friction. Second, it is written as acceleration with which the cylinder rolls down. So I have acceleration as 2 by 3 g sine theta, friction as 1 by 3 mg sine theta, and the minimum value of coefficient of static friction is 1 by 3 tan theta. This is the coefficient of friction. So when I substitute these values, you will get easily. So this is one typical kind of question, just go through it. I think it is, since it is typical, so it is going to help you a lot.